I drop down the 1. 1 times 2 is 2. What do I do vertically? Add. So 0 plus 2 gives me 0. Or 2, sorry. I want to make sure my mic is fine. 2 times 2 is 4. Negative 7 and 4 gives me. Negative 3 times 2 gives me. Negative 6 to give me 0. What does that 0 indicate? It is a factor. So therefore, now, what degree is this going to be? It's degree 2. Why is it degree 2? Because my highest exponent was 3, and once you do synthetic division, it's 1 degree smaller every time. Okay? So now, what's my polynomial that I have left? X squared plus 2x minus 3. Now it says, in the remainder of the directions, it says, and use the result to factor the polynomial completely. What's another name for a factor? How about an x-intercept? How about a solution? How about a 0? Okay? Those are all answers or synonyms for factor. Okay? Which means if I want to find the factors or the roots or the zeros or the x-intercepts, that means if it's an x-intercept, what is y? 0. Which means I set this thing equal to 0, and now I need to solve this thing for x. So how do I solve this thing for x? Well, when in doubt, always try to factor into two binomials. So this gives me x, and I need factors of 3. The only factors of 3 are 1 and 3. I need to have a negative 3, which means my signs have to be opposite. But I need them to be a positive 2. So that gives me a plus 2 minus 1. Plus 3, sorry, minus 1. So x plus 3 is equal to 0. X minus 1 is equal to 0. So x is equal to negative 3. X is equal to positive 1. Did I find all of my zeros and all of my factors? I did. Okay, and now I know what this thing looks like. Okay, do we understand that? Do you know how to do 11 through 14 now?
We do 12. 12 is not working. I tried telling her, but she said it works.
Oh, Trish, I did correct that on my paper. Trish is right. You guys are right. Number 12, that needs to be a positive 48.
That's just sad. I knew I was right. Sometimes, whenever I'm typing these up at home out of your book, I just don't always get the right thing. But you guys should be glad that I at least made you a worksheet.
Thank you.
So you guys said that needs to be a positive 48.
Oh, sorry. It did not. It did not. Yes, it did. No. Yes, it did. Pictures do not mean that they are
I texted her when I saw the picture on Instagram at lunchtime.
No.
Yes.
It was not there.
Yes, it was. Yes, it was.
I've heard it was.
It was not with your liar.
Okay, now the other one, number 7. Number 7 is a little bit harder. How many of you tried to use decimals in this? How many of you tried to use decimals in this? No decimals. No decimals. You know why I don't want you to use decimals? Because the square root of 2 is what type of a number? It's an irrational number, and since it's an irrational number, I cannot allow you guys to use decimals because the irrational number never ends. Okay? It never ends, and it never has a pattern, so it's not an accurate value. Do we get what I'm just saying here right now? Okay? So what we have to do is I want you to do synthetic division of this thing. And I'm missing, am I missing any powers? 3.
No.
Aww. 3, 2, 1, 0. Am I missing any powers?
Nope.
No. I said dumb things.
Say you're sorry.
No, it's a dumb thing. Sorry, board.
No.
Negative 3, 8, 10, negative 8. So I drop the first one down, and I get what? Negative 3. So negative 3. Then I'm going to multiply negative 3 by a binomial. Do you see that? So what am I actually doing? Distributing. So negative 3 times 2 gives me negative 6. Negative 3 times the square root of 2 is going to be negative 3 square root of 2. Why do they not line up?
They don't have that now.
Because I have a rational number lined up with a rational number, and my irrational number is lined up with this irrational number, and there isn't one for a like term on that. So what's 8 minus 6? 2 minus 3 square root of 2. Do we see that? Now I have a binomial times a binomial, correct? So what do I need to do? We have a method. That method's called FOIL, right? So I have 2 plus the square root of 2 times 2 minus 3 square root of 2. I need to FOIL those together. So if anybody uses decimals, Yoder's not playing that way. We do not want decimals, okay? So what's 2 times 2? 4. 2 times 3 is going to be negative 6 square root of 2. Square root of 2 times 2 gives me plus 2 square root of 2. Square root of 2 times the square root of 2 is square root of 2 times the square root of 2 would be the square root of 4, which is 2. Do we all understand that? So now I have 2 times 3, which gives me minus 6. Does everybody understand where that minus 6 came from?
No. Oh.
Wait, what?
You got to finish the question, Booker. I don't know what you're saying.
Is the 3 a part of square root?
Is the square root of 4? So what's the square root of 4? 2. And what's 2 times 3? 6. We good? Yeah? Okay, do I have any like terms? 4 minus 6 gives me negative 2. And negative 6 square root of 2 plus 2 square root of 2 gives me negative 4 square root of 2. Okay, so that is going to go right here. So that's going to be negative 2 minus 4 square root of 2. Yeah, it's ugly.
It's really ugly.
Not going to lie, it's ugly. Okay? Now what's 10 minus 2? 8 minus 4 square root of 2. Okay, so now what do I do? Same thing. So I'm going to have 2 plus the square root of 2 times 8 minus 4 square root of 2 is equal to 2 times 8 is 16. 2 times 4 is minus 8 square root of 2. 8 times the square root of 2. And then square root of 2 times the square root of 2 is 2 times 4 is minus 8 here. What happens to inner and outer? Let's cancel out and left with 8. Now, what does this tell me? That's a factor because the remainder is 0. Okay, now the direction said to write that in a very specific form, right? It said to write it in the form of the x minus k times the q of x plus the r of x, right? So what is x minus k here? Well, this is going to be x is equal to 2 plus the square root of 2, correct? Which means I need to bring the 2 over and I need to bring the square root of 2 over. So what's that going to be? X minus 2 minus the square root of 2. Correct? Do we all see that? And then what degree is this right here?
2.
It's going to be degree 2, so that's negative 3x plus squared plus, watch this, 2 minus 3 square root of 2 times x. That's the coefficient of the x term. I put it in parentheses so you see that whole number is the coefficient. Not just 3 square root of 2, but 2 minus 3 square root of 2. Okay? And then plus 8 minus 4 square root of 2.
I am too.
Do we understand this? This is your answer.
I think we should just go in and let us go.
Do we understand that, yes or no?
No.
Okay. Do you understand synthetic division? Okay. So you don't understand the part where I boxed in? Okay. This is K. This is X equals K. But I need it to be K, X minus K. Okay? This is K. So to bring K on the same side of the X, I have to subtract it from both sides. That's why I have X minus 2 minus the square root of 2. Steph, you with me on that?
Why do you put that out front? I know where you're moving.
Why do I put this out front? Because the directions say you always put X minus K out front. You with me? Then this is my q of x. Okay? That's degree 2 now, and I bring it down. Why is this in black? So that you understand that this is a one number together as a coefficient. Because what oftentimes is you think that the 3 square root of 2 will be the coefficient, when it's not. It's 2 minus 3 square root of 2 because it's that irrational concept. Right? Do we understand that a little bit better? All right. R of x is 0, which is why we don't need it. Okay? Do we understand that now? Okay, excellent. Now, your homework is to make sure that worksheet is done. I want it completely done by Monday. If it's not done, you get zeros. Am I clear on all of what I just said? If it is not completely done, it's a 0 by Monday. Now, today, it's all about listening skills.
Thank you.
The other cousins are in jail. Go Billy.
It does. That's okay. Okay. Here's the answer sheet. All right, now, today, what are we talking about? The first slide, we've already talked about the factor theorem and the remainder theorem, right? Okay, what I want to talk about today is the rational zero test and Descartes' rule of signs. The rational zeros test. A rational number is exactly what, folks? A rational number is any number you can write as a fraction. That's a rational number. Meaning it's a decimal that terminates, or it's a decimal that never ends as a pattern. Like 1/3, 0.3333 repeating, or 1/2, 0.5. Do we get that, yes or no? So the rational zero test says given a polynomial f of x with all coefficients being integers. Okay, there's a lot of vocabulary in there. Talk to me. First of all, what's coefficients? Number in front of the letter. And what's an integer? Be positive or negative whole number including 0. In other words, can it be a fraction? No. Okay? So we're talking a polynomial with all whole number, positive or negative, coefficients, right? Then p divided by q is all the possible rational zeros of a function. Rational mean all fractional, okay? Where p are all the factors of the constant. What's a constant? The number without the variable. And q is going to be all the factors of the leading coefficient. What's the leading coefficient? The number in front of the highest degree variable, right? That's what makes it the leading coefficient. The leading coefficient. Do we understand that? Now, why would I want to use this? Now, whenever you graph something, wouldn't it be nice to be able to say, okay, I know that this function is going to cross the x-axis between the values negative 20 and 20. Wouldn't that give you a really great idea of where your window should be on your graphing calculator? Instead of saying, you know what, I have this function, and its zeros could be anywhere between negative 5,033 up to 2,052. That's a big window size, right? Are you ever going to be able to zoom in very well without having a region and have an idea of what's going on? Probably not. So what the rational zero test does is it gives you all the possible rational zeros. Okay? Now let's talk about this. We've seen this before. The real number system is the mom. The mom had a set of twins. Okay? The mom's twins were labeled rational and irrational. The irrational twin was mean and vicious and selfish. It's hard to work with, it's hard to get along with, and it requires you to do all the work by hand. What makes you do all the work by hand is the quadratic formula, because that's the only way you can get the square root, or you can get pi or anything like that, right? Do we understand that? So whenever you use the irrational number system, you're using the quadratic formula to get the square roots, okay? Then we had the nice twin who was very kind, considerate, did everything for all his younger siblings. Okay, well, it had younger siblings. The rational number system is going to be the big, big sibling. And it was all the fractional numbers in the world. You with me? 1/2, 1/3, all those jazz things. And all of that can be simplified. 10 divided by 2 is a fraction. It's a number 5. 5 over 1 is a fraction, right? Then it had a little sister that was just like it. Its little sister was the integer. But that was very picky. It was only the positive or negative whole numbers, including 0. Then we have the whole numbers, which is also known as the natural numbers. And those are just the counting numbers from 1, 2, 3, 4, all the way to infinity. Do you understand that? Okay? So whenever I say a rational number is also a natural number or a whole number, and which is also an integer. Do we get that? So these are all the type of values that we're going to deal with today. Those are your P over Q values. These are the ones that our brains like to deal with. The irrational number systems are only used by getting the quadratic formula. Okay? They're only found by using the quadratic formula. Now, then we have another tool that's extremely helpful. This is Descartes' rule of signs. Love, 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 love this theorem. You know why I love this theorem? It's because let's say I graph this thing, and this is degree 5. Okay? Let's even go down to degree 3. Degree 3, how many zeros am I supposed to have? 3. Well, how do I know how many positive zeros I'm going to have versus how many negative zeros I have? Well, this says I have 2 positive zeros and 1 negative zero, right? So I can draw it like this. That one says I have how many positive zeros? How many negatives? None. I can do it over here. How many negatives do I have? 3. How many positives? And then I can draw another one where it's going to be, and let's do this. How many negatives do I have?
2.
How many positives do I have? 1. Wouldn't it be nice? Now I would be able to have a theorem that's going to tell me that. Wouldn't it be nice? Would it be nice? That has a theorem that's going to tell me absolutely how many positives I'm going to have and how many negatives. Because then, once I get my window size where I need to be, do I have to look any further for any positive roots if I know I'm only going to have so many? Well, that's what Descartes' rule of signs does for us. What it says is it gives you the number of positive roots, and it tells you the number of possible negative roots you can have. Taylor.
I have my phone.
Now, to find the positive roots, you're going to count the number of sign changes in your original f of x function or p of x function. Then, it's going to be n or n minus 2. For example, let's say the number of sign changes that I had was going to be 4. N is equal to 4. I can have 4, 4 minus 2, which is 2, 2 minus 2, which is 0, which means I can have 4, 2, or 0 positive roots. You keep going down, because what if I do 0 minus 2? What's 0 minus 2? That's negative 2. Can you have a negative number of roots? No, because you're counting, which means it always has to be positive, which means that's not positive. Possible. You keep going until you get down to the lowest positive number you can get. Does that make sense? So, for example, if n is 7, I can have 7. What's n minus 2? 5. What's 5 minus 2? 3 minus 2? And 1 minus 2? Negative 1. I can't use that one. So how many possible roots could I have? 7, 5, 3, 1. Do you understand that? Because n is the number of sign changes. It could be x, but they always use n so that you know that it's not the variable x, which is generally in a polynomial. That's just the theorem that they came up with. I have no idea why. It's the theorem that some guy decided to say too. Something that's been memorized. I'm sure there's a reason out there. If you find it on the internet, I'll give you extra credit. Not that important. Not that important. All right, finding the negative roots. Finding the negative roots, instead of counting the number of sign changes in p of x, you're going to count the number of sign changes in p at negative x. What does that mean whenever you're doing p at negative x? Every time you see an x, what do you replace it with? Negative x. Well, you're still going to count the number of sign changes. However, my question to you is, when you're doing this, if I have x to the third, and if I replace that with negative x, what's negative x times negative x times negative x? Negative x cubed. Now what's negative x squared? X squared. So what this means is the only thing that's going to affect replacing x with negative x, the only degrees that are going to be affected by this are degrees that are what? Odd. Even ones will not change, right? Even powers will not change, but an odd power sign will change. And we'll talk about that here in a minute. Now, the next sign, the next slide. Now, we talk about P over Q. What does P over Q do for us? The possible zeros, and what does it do to my window? Shrinks your window down so that you can see all your possible rational zeros. What does Descartes do? Tells us the number of possible positive roots we have and the number of possible negative roots we have, right? Now, the next thing we need to talk about is the discriminant. Now, the discriminant is that lovely x equals negative b plus or minus squared root b squared minus squared c all over 2x, right? That's our lovely quadratic formula. The discriminant is what's underneath the square root. Now, why would this be important to us? Because the quadratic formula helps us to figure out what a function looks like on the coordinate plane. Okay? If my discriminant, which is b squared minus 4ac, is greater than 0, that means I'm taking the square root of a positive number. Can I take the square root of a positive number? Yes, which means I can visibly see it crossing the x-axis in two places. Does that make sense? Yes? Now what happens when my b squared minus 4ac is less than 0? That means I'm taking the square root of a negative number. Can you take the square root of a negative number and be on the real coordinate plane? No. So what I'm asking you is, can you see them when you graph it? Can you see where it's crossing the x-axis? No, because it's not crossing the x-axis. What we have are two imaginary roots. What does the graph of that look like? That. It never crosses. Do we get that? Now, b squared minus 4ac is equal to 0. When it's equal to 0, that means that this thing has a double root. Because what's the square root of 0?
0.
Does it change the quantity of the b squared or negative b? No, it doesn't. Which means this thing is a double root, meaning it is touching the x-axis at one spot and coming right back up, meaning it's a double root. And we talked about that previously. Okay, so P over Q, Descartes, and discriminant gives us a lot of information about what our function looks like. Now let's actually start this bad boy. So here we go. F of x equals 2x cubed plus 3x squared minus 8x plus 3. The first thing I want you guys to do is I want you to find your P over Q value. So what's P again? It's the factors of your constant terms. What's my constant term? My constant term is going to be a 3. So if P is equal to 3, what's Q? Q is equal to my leading coefficient. So what's my leading coefficient? 2. So now here's the question for you. What are all of the factors of 3? 3 and 1. So I'm going to have plus or minus. Why do I have plus or minus? Because what's 1 times negative? What's negative 1 times negative 3? Positive 3. So can you forget the negative numbers here? No, you have to include them, which is why you're going to have plus or minus. Now, what are all the factors of 2? Plus or minus 1 and plus or minus 2. Now, do you notice how I put a plus or minus out in front? Once you have the plus or minus on the front, you don't have to write it down for every single one of those. I understand that you mean that that's the entire list there. Does that make sense? Now, what we're going to do is we're going to make a complete list of these. So now, what is plus or minus 1 divided by plus or minus 1? 1. What's plus or minus 3 divided by plus or minus 1? 3. Now, what's plus or minus 1 divided by 2? 1/2. And what's 3 divided by 2? 3/2. This is the complete list of all of the possible rational zeros that that function f of x can have. Doesn't that really change the view of what your zeros are going to be? Doesn't this tell you right away that if it's not plus or minus 1, 3, 1/2, or 3 over 2, then what am I having to do here? I need to do the quadratic formula. If it's not the quadratic formula it's going to get it, then that means they're going to be imaginary roots. Does that make sense? Okay? Now, can you tell me what my window should be? What's my largest number? My largest possible root.
3.
My largest possible root is going to be 3. So what's my smallest possible root? Oh, come on, don't forget those negatives, folks.
Small.
If 3 is my largest, then negative 3 has to be my smallest. Now I want to see if 3 and negative 3 are going to be roots, so what should I put my window size out to be? Probably 4 and negative 4. So I might want my window size to be negative 4 to 4. Do we understand this? That makes my window size something small that I can see. There's no doubt that it's going to cross in there or not. Do we all understand that? Okay. Now, same exact problem, but this time I want you to apply the Descartes rule of signs. Okay, we don't have enough time for this today. Tomorrow, Monday in class, we're going to go over this again. Do you know why I did not give you guys homework? Because this is still, no. Okay, nice. But because there's a lot of notes going on here today, this section has a lot of theorems, and you need to understand them to fully grasp what we're going to be doing next week. So Monday when you guys come in, we're going to make sure that worksheet's done, and we'll finish off the notes.